Hi everyone, this is going to be the last video for this week. Let's start with just an example here. Write sine of 2 cosine inverse x as an algebraic expression in x. A problem that we have worked with before, and I go ahead and I do the same thing that we've done before. Let 2 cosine inverse x be u. That means cosine inverse x is u over 2, or x is cosine u over 2. And you notice that the difference from the previous example is that now I have a cosine of u over 2 instead of u. And that's because we just learned all these half angle, double angle relationship. So what is our goal? Our goal is to find sine of 2 cosine inverse x, which is sine of u. So I know cosine of u over 2 and I'm trying to find sine of u. What would be a smart way to go about this? Well, one way to go about this would be, again, to use the identity sine squared x equals 1 minus cosine 2x over 2 use this triangle here. So u over 2 has the ratio adjacent x hypotenuse 1. So this is square root of 1 minus x squared. Now here we got to be careful. Let's say I substitute u over 2 for x, right? What am I trying to find? I'm trying to find sine u. So if I can find cosine u, let's use the other one. Let's use what's that? Cosine squared x equals 1 plus cosine 2x over 2. And then let x equal u over 2. Then what I have is cosine squared u over 2 times 2 minus 1 equals cosine u. But what is that? That's 2 times cosine u over 2 is x. So this is x squared minus 1 is cosine u. If 2x squared minus 1 is cosine u, then sine u is 1 minus 2x squared minus 1 squared. This is essentially square root of 1 minus cosine squared u. Let me redo this question in a different manner. I think that looks kind of ugly there, the way I did it. As algebraic expression in x. Okay, let's instead of plugging the whole thing, let's take cosine inverse x as u, then x is cosine u, and what we are finding is sine of 2 cosine inverse x, which is sine of 2u. I think that's more manageable, because then that is 2 sine u cosine u. But if cosine u is x, then this is square root of 1 minus x squared times x. So it's just 2x square root of 1 minus x squared. Now on the face of it, this looks way simpler and quite different from what we have here. But the point is that if you were to simplify this, a bunch of things would factor out common and you would end up with the exact same thing, because they have to be equal. Okay. Now we changed, we had the sum of angle formulas, and they can be used to derive this other relation between product of things. How? You can check for the bottom three, and I'll show you how it is for the first one. All you have to do is just use the sum formula, right? So if you look at the RHS, this is 1/2. You get sine A cosine P plus cosine A sine B plus, but sine A minus B gives you sine A cosine B minus cosine A sine B. So these cancel out. So it's 1/2 times 2 sine A cosine B, 2 cancel out, which is the left hand side. Now try that for the other three, just for practice. These kind of formulas are called product to sum formulas. The last one is sum to product. Usually that's how the structure is. If you have product to sum, you want to be able to go either ways. And these can actually, again, I'm going to show you the first one. If you think about these, this is just 2 times sine of A plus B over 2 cosine A minus B over 2. And what does our product to sum formula say? If you have sine A cosine B, it's 1/2 sine of A plus B and sine of A minus B. So in our case, this whole thing is going to behave like A, and this whole thing is going to behave like B. So we end up with 1/2 sine of A plus B, which is A plus B over B plus A minus B over 2, plus sine of the first minus second, so A plus B over 2 minus A minus B over 2. 2's cancel, so this is sine 2A sine 2B, 2's cancel, sine A plus sine B, which is LHS. So again, for practice, try and show that these are correct and true as well. Now these methods or formulas, you do not necessarily have to remember them, but you do have to know that they exist, which means that you need to be aware that, for example, sums of trig functions can be written as products, and products of trig functions can be written as sums. And you should be able to get the formulas and use them. Yeah. So more important than knowing what these formulas are, because there's a whole bunch of them, you need to know that they exist and when to use which one. Okay, that's it for week 2. We still have a little more of trigonometric stuff that we are gonna go ahead and finish in week 3, but that's about it for week 2.